Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle, I'm taking a sort of, I usually don't do these puzzles because I'm not the biggest fan of 6x6 Sudokus, but this puzzle has a musical connotation to it. So, I've done music pretty much all my life. So I enjoy music. So anything with the music theme, I'm kind of a sucker for. So anyways, let's get to the puzzle. Today's very easy puzzle is called Super Imposition by GDC. And here are the rules. We have normal Shuberku rules apply. I don't know what that is. Okay, well, maybe we. It sounds like it's from Schubert, Schuberku. Anyways, let's see what that means. Place one or two of the this is superimpositions. So place one or two of the letters A through G in every cell, such that each letter appears exactly once per row, column, and box. Okay. Right. So this is place one or two of the letters A through G in every cell. So I guess I would put it this way. In every cell in the grid, place one or two digits or one or two letters from A through G such that each letter appears exactly once per row, column, and box, or designated 6-cell region. Okay, so that is Schuberku rules, which I'm pretty certain comes from Schubert. Was his first name is Franz Schubert? I've always known him as Schubert. I never really pay attention to the first name. So, but yeah, this is based off of Schubert, and we have the letters A through G, which signify the main tones of a major scale, starting from C. So that's the musical aesthetic. It's superimposition because we have to have a Schrödinger cell, essentially, which contains two digits again, somewhere in the puzzle, or multiple times in the puzzle, because every row, column, and designated 6-cell region must contain each letter once from A through G. So that is normal Schuberku rules. We have values, where the value of a cell is the musical note corresponding to its letter. If two letters share a cell, they must be two semitones apart, which means a half step, and represent the note of the black key between them. Okay, so the value of the cell is the musical note corresponding to its letter. If two letters share a cell, they must be specifically two semitones apart. So they cannot be like E and F, because that's only one semitone apart. But they could be like C and D, they could be D and E, they could be F and G, G and A or B. Those are the possibilities for sharing a cell. They have to be two semitones apart and represent the note of the black key between them. For example, if row 1, column 1 contained both C and D, its value would be C sharp or D flat, right? Which is the black key in between the white keys. Actually, I guess, yeah, A through G represent the white keys on a piano, I guess, if you would put it that way. And a cell that has a Schrödinger ability, which means it contains two different letters, it represents a black key. It must represent a black key in the piano scale. So, for example, if you had C and D, it would represent C sharp and D or D flat, which is the same tone. So yeah, that is what the values of each cell would be. And finally, we have hear and play cages, where values in a cage don't repeat, and they form the indicated major chord on and in any order. Okay, so you're going to have to know some basic music theory. So this is going to be an E flat major chord. This is an A flat major chord, and this is a D major chord here. Okay. What that tells us then, okay, so I will give you a hint if you don't have music theory. A E flat major chord is E flat, G, and B flat or A sharp, essentially. But since it's an E flat, it has to be it's specifically E flat, G, and B flat as the values here. For an A flat chord, it's A flat, C, and E flat to be a major chord. And for a D chord, it's D, F sharp, and A. And that's just the way that you basically have, what is it? I think it's 2 whole steps, which is 4 semitones, difference from the bottom cell of the bottom note of the chord. That gives you the major third interval. And then you have a perfect fifth interval, which is 3 semitones above the third. So seven semitones total above the bass tone of a chord. That's how you get this, that you know E flat goes to G, because you have E flat. Is that right? Yeah, that's right. E flat to F, E flat, E, that's 1, to F flat. Actually, there's no F flat. E flat, E, that's 1, to F, that's 2, F to F or G flat, that's 3, and then to G, that's 4. So that's 4 semitones. And then you have G to A flat, which is 1, A flat to A, which is 2, and then A to B flat, which is 3. So that shows you how to build a major chord with these letters. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to play music and Sudoku. Okay, so we have E flat. So, okay, we have to have all 7 letters, all 7 notes in every row, column, and designated 6 cell region. That means you're going to have 1 Schrodinger cell per row, per column, and per region. So there has to be 1 of these, there has to be 1 here to form an E flat and a B flat. So these have to be Schrodinger cells, which means we don't have a Schrodinger cell in the same regions, rows, or columns. So these cannot be Schrodinger cells here. Now D also has to have an F sharp, so this must be a Schrodinger cell here, which means this is not Schrodinger cell, and this is not Schrodinger cell. A flat, again, requires A flat and E flat, so it requires 2 Schrodinger cells, so they must both be here, which eliminates Schrodinger cells here. And here, that leaves this as a Schrodinger cell here. So again, D requires F sharp, which is between F and G. So this must be a combination of F and G. We also have somewhere a D and an A. right? So this is A and D, F, G. That leaves the remaining digits in row 6 as B, C, and E. That means this is B, C, and E. So we have A, D, F, and G here. So this has to form a flat. And it would be either A flat or E flat. Well, it cannot be E flat because E flat requires E to be with it. So it would be E and D. So it has to be A flat here, which means it's between A and G. So this is A and G, which eliminates A, G here. This must be E flat then. And then we have also A flat, C, and E flat. E flat is between D and E, so this is C, which eliminates C here. This DE pair eliminates D here, so this is F, that's D. Okay. This single cell must be a G, right? Because we have E flat, G, and B flat. So this is G. That means where's G in row 4? Cannot be any of these cells, so it must be here. So this is G. We have G here and G here. We have G here and G here, so G is one of these two. G has to be one of those two. Okay. E flat is E and D again. So this could be here or it could be here. We don't know. And then the other one is E flat, G, and B flat, which is between A and B. So we have E flat between D and E, and or A flat, no, B flat, which is A and B. Okay. Either way, this cell, okay, so, remaining cells in this region in the right central cell. It must be A, B, and F, which eliminates A, B, and the rest of the row. So this can't be A, B. This is D and E, so that's E flat, which means this can't be D and E. This is A flat here. So we have E flat, G, A flat. So that works there. A and B eliminate A here, so this is D, which makes that A. It also eliminates B here. This D and E eliminates E here. So we have A, B, and F here. This can't be F because of the F in the column. That leaves this cell as C. That eliminates C here. Okay. This cannot be A because of the AG pair in the column. This can't be E because of the DE pair in the column. This cannot be A, B, D, or E. So it could be C, F, or G here. We have G here, G here. Remaining cells here are A, B, and F. And this can't be A. This can't be A. So this must be A here. This can't be B because of the AB pair, eliminating AB in the column. So this is F, that's B. So we have F, F, and this, where is F in column? This B eliminates B here, so it's C. This then becomes an FG pair. So this is F or G. This is A, B, so this is C or E here. C cannot be here, so C has to be here. The C eliminates C here, it's E, B. That makes this C. This must be D and E as a pair. We don't know which one's which. Okay. A and B cannot be here. Remaining letters would be what? C through G. C, D, E, F, G. This cannot be D, E, or F. This can't be D or G. This can't be C or G. Okay. So C is one of these two. Letters here cannot be C, D, or G. We could have A, B, E, or F here. Okay, F cannot be. Um. Hmm. I think that's all we have. Remaining digits in row 1 are A, B, D, E, F, and G. This can't be D or E or F because of the D, E Schrodinger and the F in the column. This can't be A or G because of the same thing. So D has to be one of those two. Hmm. I'm not sure how to actually disambiguate this right now. This is an FG pair. So B flat, which is between A and B. E flat, which is between D and E. F sharp, which is between F and G. A flat, which is between A and G. E flat, which is between D and E. But then how do we disambiguate this? Huh. Oh, okay. The Schrodinger has to be again between two cells, two tones that are two semitones apart. A, it has to be a pair of either A, B, or E, F, and E, F is only one semitone apart, right? C, D, E, F. There's two white cell keys next to each other, so E and F cannot be here. A and B are not next to E and F. Huh. So this is all stuff, unfortunately, that you have to know as a musician. But A and B eliminate A and B in the rest of the column, so this can't be B, A, and B. That's F, which makes this B, which makes that A. The B eliminates B here, so it's E. This can't be B or E, so it's C, which makes this B. A and B eliminate A and B here, so it's G, which makes this C. This can't be C or F, it's E. G eliminates G here, so it's F and G. E eliminates E here, so it's D and E. D and E eliminate D and E here, so it's F, which forces this to be a D. And that's a solution. Pretty cool. Yeah, you have to remember, I guess, all the rules here, because that's required to know this. I guess I should have, yeah. It's hard because you essentially have to teach like a little bit of music theory here to give everybody all the information to solve this, and I forgot about that here. But this was a nice, fun little exercise. Yeah, it just kind of shows like how you can sort of expand on Sudoku stuff, which is this is pretty cool actually. I enjoyed this. I hope you guys learned a little something, and maybe you learned a bit about music theory here. Probably not very much, but yeah, it's hopefully it was understandable for those of you who don't have music backgrounds. But I don't know. It's as I said, I've done music basically all my life, um, and it's sort of in just you sort of have the ingrown knowledge that you sort of just apply immediately. That I don't know if it's very clear. It's kind of like actually with like doing Sudokus in a sense, because you just do if you've after you've done so many, after you've played so much music and you have basic music theory like sort of drilled in you, sort of like basic Sudoku theory, you basically start doing things sort of on intuition, I guess, a little bit, but also just like it's something that you have so ingrained in you that it's sometimes hard to know how to talk about it because it's just like, oh yeah, there's between A and B, those are two semitones already. Or like you have an A flat major chord. Okay, you have to have A flat C and E flat, right? It's just like something that you already know. But it's the same thing with Sudoku too, right? Where you basically are like, oh well, obviously this you have a certain 2 and 4 here that eliminate, or D and G here, which eliminates D and G in the rest of the row. So therefore we have to have D and G here, etc., etc. So it's kind of similar in that sense. Anyways, I hope you enjoyed this episode of Learn How to Shubertu, I guess. And I'll see you next time on Frank Puzzles. Take care.